Hey, so we're down to one last topic in chapter 17 dealing with equilibria, and that is complex ions. And complex ions come about when metal ions like copper 2 plus, iron 3 plus, iron 2 plus, cobalt 2 plus, cobalt 3 plus, any of those metal ions act as Lewis acids and pick up pairs of electrons. The resulting molecule or ion we typically call a complex ion, because it is something that carries a formal charge oftentimes, but is not just a standard ion like cyanide ion or hydroxide ion. It's a metal ion that has what we call ligands. They're molecules or ions that are attached to it through Lewis acid-base reactions. And the most common one that we encounter in an initial stage of a discussion like this is copper 2 plus. Copper 2 plus can form a complex ion with several different ligands or different molecules. So it's forming a complex ion. In the case, I'm going to show you a demo here in a second. It's going to form a complex with NH3 or ammonia. So I've got a copper solution and we're going to add ammonium hydroxide to it. Ammonium hydroxide is the base form of ammonia. So we have NH3 in the solution, NH4 plus because that's a conjugate acid base pair, and we also have hydroxide ions. All three of these are present in solution in pretty good quantity. And so what happens when we start to mix these together, copper along with ammonium hydroxide, is that first we're going to see CuOH by 2 forms. And the KSP for that is 4.8 times 10 to the minus 20th. So it won't take very much hydroxide in our solution before we start to precipitate the copper 2 hydroxide. But as we keep adding the ammonia, we're going to shift the equilibrium. We're going to overwhelm the copper hydroxide equilibrium with extra NH3. And copper can accept up to 4 NH3 molecules. So it's tetra ligand. So copper tetra ammonia complex. And we will be able to know that that happens because there's going to be a distinct color change that occurs as we switch over from copper 2 plus in solution by itself to copper hydroxide. That's a precipitate. So we'll see a cloudy solution. And then as we keep adding ammonia, we're eventually going to move on to the copper ammonia complex. And all of the copper hydroxide that we precipitated is actually going to redissolve because we're changing what equilibria is available to the copper in solution. Okay, so I'm going to stop here. We're going to set up the demo and then we'll come back. We'll show the demo, okay?